Students, in this class we will discuss this question: 2 times sine of theta positive 30 positive 5 times cos 30 cos theta is equal to 2 times sine theta, where theta lies between 0 and 90. So we are expected to solve this. So foremost, let us consider 2 times sine of theta positive 30 positive 5 times cos theta is equal to 2 times sine theta. Now I would be using this formula, sine of A positive B, which is sine A cos B plus cos A sine B. Now using this formula, I can rewrite the given question to be as 2 times, in place of sine of theta positive 30, I'm going to use this formula and write it as sine theta cos 30 positive cos theta and sine 30 positive 5 times cos theta is equal to 2 times sine theta. Now this is going to be, now you know that cos 30 is root 3 divided by 2, and sine 30 is 1 over 2. Now we know these two important facts. So because of that, I would be rewriting this given equation as sine theta times cos 30 is root 3 over 2 plus cos theta times sine 30 is 1 over 2 positive 5 times cos theta is equal to 2 times sine theta. Now if I were to multiply the 2 inside, I would get sine theta times 2 times root 3 over 2 positive cos theta times 2 times 1 over 2, and that has to be added with cos of theta with the 5 there, and that is equated to 2 times sine theta. Now clearly the 2's that you can see here can be cancelled, and that would give me root of 3 times sine theta. The 2's can be cancelled, giving me cos theta there, positive 5 times cos theta is equal to 2 times sine theta. Adding these two together would give me root of 3 sine theta positive 6 times cos theta is equal to 2 times sine theta. Now if I were to move sine theta to the left and I would move this cos theta to the right, I would have root of 3 sine theta negative 2 times sine theta is equal to negative 6 times cos theta. Now if I were to take sine theta out, I would have root 3 negative 2 is equal to negative 6 times cos theta. Now I want to bring cos theta down and move this root 3 negative 2 to the right, so that would mean sine theta is equal to, in fact cos theta comes down, so you place the cos theta there, and on the right it's going to be negative 6 divided by root 3 negative 2. Now this is going to be tan theta, right? Sine theta over cos theta is tan theta. Now if I were to take a negative sign out of the denominator, that would give me 2 negative root 3, and on the numerator you got negative 6. So these two can become positive. So therefore you have tan theta to be equal to 6 divided by 2 negative root 3. Now you know the value of root 3 is 1.7321. So 2.000, you subtract 1.7321, that would give you 9, 7 and 6, and 9, that would be 2 there, and this is going to be the value. So this is nothing but 6 divided by 0.2679. You would get approximately 22.39. So that would mean tan theta is equal to 22.39. So theta will be tan inverse of 22.39. Now tan inverse of this would give you 1.526. This is in radians, okay? But if you want to convert this into degrees, then you will have to multiply 1.526 by 180 and then divide by pi. So that would be giving you 87.403 degrees. So this would be your final answer. We're given the question, find the quotient when 4x cubed positive 17x squared positive 9x is divided by x squared positive 5x positive 6 and show that the remainder is 18. So foremost, you draw something like this and then place the quantity, the polynomial given 4x cubed positive 17x squared positive 9x. Now this has to be divided by x squared positive 5x positive 6. Now draw a line and then place 4x cubed here. Now you have to figure out what number you should multiply with x squared so that you get 4x cubed. Now clearly that number is going to be 4 times x, because 4x multiplied with x squared would give me 4x cubed. 4x multiplied with 5x would give me 20x squared positive 4x multiplied by 6 would give me 24x. Now you change the sign, plus is your minus, plus is your minus. So 4x cubed can be cancelled. You got 17x squared minus 20x squared, so that would give you negative 3x squared. Now 9x negative 24x, so that is going to be negative 15. Okay. Now what you need to do is draw a line and then place negative 3x squared. Now you have to figure out what number you're going to be placing here, so that number multiplied with x squared would give me negative 3x squared. So clearly that quantity has to be negative 3. Negative 3 multiplied with x squared would give me negative 3x squared. Negative 3 multiplied with positive 5x would give me negative 15x. And then negative 6 multiplied with positive 6 would give me negative 3 multiplied with positive 6 is going to give me negative 18. Okay, so that's going to be negative sign there. Now minus there, change the sign plus, minus is here, change the sign as plus. Now you got a negative there, so this means you have a constant 0 there. So negative is here, so you change the sign for negative as positive, so that would give you positive 18. So all these things would get cancelled. So the remainder for this problem is positive 18 and the quotient q of x is 4x negative 3. So this completes the solution for this question. So this is the second part of this question. We are expected to solve this 4x cubed positive 17x squared positive 9x negative 18. Now if you would have seen the previous question did not have this constant negative 18, but this question has a constant negative 18. So this would mean that 4x negative 3 is a factor of the polynomial 4x cubed positive 17x squared positive 9x. So this would mean I can rewrite 4x cubed positive 17x squared positive 9x negative 18 equal to 0 as a product of 4x negative 3, because 4x negative 3 is a factor. Now from the previous question you know that the quotient is when x squared positive 5x positive 6 divides the polynomial, we are left with qx negative 3 as the quotient, but its divisor is x squared positive 5x positive 6. So how are we going to write? We are going to rewrite this given polynomial as the quotient, which is 4x negative 3 multiplied with the divisor x squared positive 5x positive 6 will give us a remainder 0. So from here this would mean Now from algebra you know that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. So from this important fact, 4x negative 3, if it is equal to 0, then we got 4x is equal to 3 and x is equal to 3 divided by 4. So this is the important information that we have got. So this would be one of the roots, okay, root 1. Now if x squared positive 5x positive 6 is equal to 0, then we can clearly factorize this. This can be factored as x positive 3 times x positive 2 is equal to 0, because x times x gives you x squared, x times 2 would give you 2x, 3 times x would give you 3x. So those elements added would give you 5x, and 3 times 2 would give you 6. So clearly this is the factor. So from here I can say x positive 3 is equal to 0 or x positive 2 is equal to 0. Now if x positive 3 is equal to 0, then x is equal to negative 3, and if x positive 2 is equal to 0, then x is equal to negative 2. So therefore the roots, okay, of the polynomial, what is the polynomial? 4x cubed positive 17x squared positive 9x negative 18 equal to 0 are as follows. So what are the roots? We started off with 3 divided by 4, but our convention states that we need to write from the smallest value. So that would be negative 3, negative 2, and then finally it will be 3 divided by 4. So this completes the solution for the question. Students, we are given this question: integral a to 3a 2 divided by 2x negative 5 times dx is equal to ln of 7 over 2. Now let us start by consider integral a to 3a 2 divided by 2x negative 5 times dx. Of course it is given to be as ln of 7 over 2. Now what I'm going to do to integrate the left side, I'm going to take 2x negative 5 to be equal to t. So this means 2 times dx is equal to dt, which means dx is equal to dt divided by 2. So by this substitution, I'm not going to touch the limits for now. The integrand will become 2 times, in place of dx I'm going to substitute dt divided by 2. In the place of 2x negative 5 I would be substituting t. So this 2 that you see here can be cancelled, giving me integral dt divided by t. Of course on the right side it's ln of 7 over 2. This is ln of 7 over 2. Now when a, in other words when x is equal to a, you can write it like this: when x is equal to a, what happens? You get 2a negative 5, right? For t the limits is going to be 2a negative 5, the lower limit. And then when x is equal to 3a, the limit, this is the value for t, okay, t is equal to this. So when x is equal to 3a, the value of t is going to be 2 times of 3a negative 5, which is 6a negative 5. This is the value of t. Okay, so this is the value of t. Now you can place that on the head of the integral sign. So this is going to be 6a negative 5. Now if you apply the limits, or before you could apply the limits, integrating, you need to integrate. So integrating, we get, so what do we get when we integrate? Integral of dt over t will give me ln t. The limits are 2a negative 5 and then 6a negative 5 is equal to ln of 7 over 2. Now substitute the upper limit, you get ln of 6a negative 5 followed by the lower limit, which is 2a negative 5, which is equal to ln of 7 over 2. Now I know a formula: ln a negative ln b is equal to ln of a over b. So by this formula I can rewrite this quantity as ln of 6a negative 5 divided by 2a negative 5, which is equal to ln of 7 over 2. Now you can drop ln on both sides. So removing, you can write the statement: removing ln both sides, we get. So what happens when you remove ln both sides? You get 6a negative 5 divided by 2a negative 5 is equal to 7 over 2. You cross multiply, you get 2 times 6a negative 5 is equal to 7 times 2a negative 5. This is going to be 12a negative 10 is equal to 14a negative 35. Now I can move 12a to this side, so that will be 14a negative 12a, and move 35 to the left, so that's going to be negative 10 positive 35. So this would become 25, and that has to be equated to 14a negative 12a would give me 2a. So therefore a is going to be 25 divided by 2, which is, okay, so that is the value of a. Students, we are given this question. A curve has equation 3x squared negative y squared negative 4 times ln of 2y positive 3 equal to 26. Find the equation of the tangent to the curve at 3, negative 1. So foremost, what we would do, we would consider 3 times x squared negative y squared negative 4 times ln of 2y positive 3 is equal to 26. Now we will differentiate. Differentiating with respect to x, we get. So differential of 3x squared would give me 6x, negative differential of y squared is going to be 2 times y, dy over dx, negative 4 is a constant, it's taken out. You differentiate ln of 2y positive 3, that's going to be 1 over 2y positive 3 times 2 is a constant, and you have to differentiate this y, so that's going to be 2 times dy over dx is equal to differential of 26 would give you 0. Now this can be rewritten as 6x negative 2 times y dy over dx, negative 4 times 2 would give you 8 divided by 2y positive 3 times dy over dx is equal to 0. So now what you can do is you can take dy over dx as a common factor and move this 6x. So in fact, if you were to do that, this can be rewritten as negative. Now dy over dx can be taken out as a factor, so this would give you 2y positive 8 divided by 2y positive 3 is equal to, now 6x goes to the other side, so that becomes negative 6x. Now we are expected to find the equation of the tangent at 3, negative 1. So that means x value is 3 and y value is negative 1. So you need to just substitute those values here and find dy over dx. And that would simplify our work to a greater extent. So y is negative 1. Okay, so place negative 1 there, followed by 8 times 2 of negative 1 positive 3 is equal to 6 times, my x is 3 there. So this can be rewritten as dy over dx of, this is negative 2 positive 8 divided by negative 2 added with positive 3 would give me positive 1. On the right it's going to be 6 times 3. I don't want to multiply 6 with 3. So this is going to be dy over dx of negative 2 added with 8 would give me 6. On the right I've got 6 times of 3. Now clearly what I can do, I can cancel the 6 that I see on both sides. So this would mean I've got dy over dx to be equal to 3. So that also means my slope is equal to 3. Now the required equation can be rewritten or written as follows. The required equation is y negative y1 is equal to m times x negative x1. Okay. Now at the point 3, negative 1, we need to get that. So that's going to be y negative of y1 is negative 1 is equal to m is 3, x negative of 3. So this can be rewritten as y positive 1 is equal to 3 times x negative 9 which means y is equal to 3x negative 9. I move this positive 1 to the right, that would give me negative 1. So this can be rewritten as y equal to 3x negative 10, which is the equation of the tangent at the point 3, negative 1. Students were given this question: a curve has equation y equal to x cubed e raised to the power 0.2x, where x is greater than or equal to 0. At the point P on the curve, the gradient of the curve is given to be as 15. We are asked to show that the x coordinate of P satisfies the equation x equal to square root of 75 times e raised to the power negative 0.2x divided by 15 plus x. So let us start off by considering y to be equal to x cubed e raised to the power 0.2x. Now we will differentiate both sides. Differentiating both sides with respect to x, we get, so what do we get? This is going to be dy over dx is equal to 3 times x squared. Now I'm going to apply UV formula. Okay, now d of u times v is equal to u times v dash plus v times u dash. Of course, now what I have done here, I have started with differentiating with the first term, and then I will follow it up with the differential of the second term. But because of consistency, what I would do is I'm going to be rewriting this step starting with uv dash formula. Okay, so dy over dx is going to be equal to x cubed times differentiation of e raised to the power 0.2x would be e raised to the power 0.2x times the coefficient of x is going to be 0.2, so place it as it is, plus now v times, so that's going to be e raised to the power 0.2 times x times differential of u dash, so that's going to be 3 times x squared. So this is what we have got. Now I would rewrite this as dy over dx is equal to, now this can be rewritten as 0.2 times e raised to the power 0.2 times x times x cubed positive e raised to the power 0.2 times x times 3x squared. So this is my dy over dx. Now we are asked to show that the x coordinate of P satisfies this. So what I would do is I would first find the gradient for this particular curve. So how are we going to do that? Now if you see here, we are given that the gradient is actually 15. Now at the point P on the curve, the gradient of the curve is given to be 15. So we can use that quantity. So we now have 15 is equal to, what I can do, I can take x squared out, I can take e raised to the power 0.2 times x out. When I do that, I would get 0.2 times x for the first quantity, plus I have taken x squared out, I have taken e raised to the power 0.2x out, so I have just got 3 there. So this is what I am getting. Now from here, I have to make the simplification and find the values for x. So I've got this 15 equal to x squared times e raised to the power 0.2x times 0.2x positive 3. I want to bring this down. So this would be 15 divided by 0.2 times x positive 3 is equal to x squared times e raised to the power 0.2 times x. I can in fact rewrite this as x squared times e raised to the power 0.2x is equal to 15 divided by, now 0.2 I can write it as 2 divided by 10 times x positive 3. Now this is going to be 15 divided by, if I were to take the LCM as 10, then I would have 2x positive 30. Okay, now what I can do, I'm going to flip this 10 to the numerator, so that would give me x squared times e raised to the power 0 times x on the left when I flip that, it's going to be 15 times 10 divided by 2x positive 30. This is what I've got. Now 15 times 10 would give me 150 divided by, I got 2x positive 30, so I can take the 2 out. That would give me x positive 15. On the left I've got x squared e raised to the power 0.2 times x. So now what I can do, I can divide 150 by 2. That would give me 75. So this can be rewritten as x squared times e raised to the power 0.2 times x is equal to 75 divided by x positive 15. So this is what I've got. Now I'm going to bring this 0.2x down. So that would mean I've got x squared e raised to the power 0.2x is brought down, so it's just x squared there. So this is going to be equal to 75 divided by e raised to the power 0.2 times x times x positive 15. Now I want to move this to the numerator, so that would give me 75 times e raised to the power. The positive power will become negative, so it's going to be negative 0.2 times x divided by x positive 15. So actually I've got x squared is equal to 75 e raised to the power negative 0.2 times x divided by x positive 15. Now I want the value of x, so I move the 2 to the other side, so that means it will become square root. So x will be equal to square root of 75 times e raised to the power negative 0.2 times x divided by, I'm writing it as 15 positive x, or you can even write it as x positive 15. This is what is required, so I'm bringing it to the requirement. So this is what has been asked. Students, in the next question we are asked to show by calculation that the x coordinate of P lies between 1.7 and 1.8. Now we know that the x coordinate of P is given, or it is of the form x equal to square root of 75 times e raised to the power negative 0.2 times x divided by 15 positive x. Now this can also be rewritten as x negative of square root of 75 e raised to the power 0.2 times x divided by 15 positive x. Now why am I writing it like this? I have to show that by calculation that the x coordinate of P lies between 1.7 and 1.8. Now the only way I can show that is by finding the value of this quantity, x negative root of 75 times e raised to the power negative 0.2 times x divided by 15 positive x. Now we will be getting two values. That means, in other words, for x is equal to 1.7 we will have a value. For x is equal to 1.8 we will have another value. Now the signs of these two values will tell us if the x coordinate of P lies between 1.7 and 1.8. Now what is the meaning of that? Now whatever sign that we get here, it should not be the same signs. In other words, if we get 1.7 for x equal to 1.7, if we are getting a positive sign, we should get x equal to 1.8 a negative sign. In other words, the signs should be different. If the signs are different, then we can surely make a conclusion that the x coordinate of P for sure lies between 1.7 and 1.8. On the other side, or on the, to say it in a different manner, the signs should not be same. So that is the check that we are going to be doing now. So how are we going to do that? So let us start by finding the value of this quantity for x is equal to 1.7. So place 75 and take e raised to the power negative 0.2 times 1.7. So that is going to give me 34, right? So since I got a decimal point here, I've got a decimal point here, so the value is going to be 0.34 times x. Of course a negative sign is there, okay, but we have actually substituted for x, so we don't need to place that x there. So we have to find the value for e raised to the power negative 0.34 divided by 15 positive. In place of x we have to substitute 1.7. Now this is taken as a square root Now let me just find out the value for this. What exactly is this? X negative. Now if you're using a calculator, you will get the following value. Now this value, when you calculate using a calculator, will give you 1.787. So now you have to substitute x is equal to 1.7 here, and then from that you got to take away 1.787. So when you do that, you are obtaining a negative quantity, right, which was going to be negative 0.087. okay, this is an approximate quantity, but the sign that matters. The sign is negative. Now what we are going to do for the second quantity, we are going to be substituting x is equal to 1.8 in the same expression. So that's going to be 75 e raised to the power negative. Now when x is equal to 1.8, that has to be substituted here, and when multiplied with 0.2 would give us 0.36. okay, now that has to be divided by 15 plus, in place of x is going to be 1.8. so we would now use our calculator and find out this value, what exactly we are getting. So this expression is actually giving me 1.764. okay, now when x is equal to 1.8, that means I have to place 1.8 and then subtract 1.7764. so what does that get me? So 1.8000 and 1.764, so 1 0 is enough. So that is going to be 10, 6, 9, 3, and this is going to be 0. okay, 0.00 positive 0.036. so the most important that we need to have a positive sign. The most important observation here is a positive sign, here is a negative sign. So this implies, without any doubt, clearly the x coordinate, this is the conclusion you need to write, x coordinate of P lies between 1.7 and 1.8. Students, we are given this question. The diagram shows part of the curve with the equation y equal to 4 sine squared x positive 8 sine x positive 3, where x is measured in radians. The curve passes, or in other words, the curve crosses the x-axis at the point A, and the shaded region is bounded by the curves and the line x is equal to 0 and y is equal to 0. So this is the shaded region. Now we are expected to find the exact x coordinate of the point A. Now this is the equation given. So let us start by consider y equal to 4 times sine squared x positive 8 times sine x positive 3. Now at A, clearly y is equal to 0. So this implies, if I were to take this as 1 would now become 4 times sine squared x positive 8 times sine x positive 3 equal to 0. Now let me take sine x is equal to some t. So that means 4 times t squared plus 8t positive 3 is equal to 0. If I were to take a to be as 4, b to be as 8 and c to be as 3 and use the quadratic formula, negative b plus or minus root of b squared negative 4ac divided by 2 times a, I would get, in place of x it is going to be t. So place the t there. My t is going to be equal to negative b, this is going to be 8 negative sign in the front plus or minus root of 8 squared negative 4 times a times c divided by 2 times a. This is equal to negative 8 plus or minus root of 8 squared is 64, 4 times 4 is 16, 16 times 3 is 48 with the negative sign, 2 times 4 will give me 8. equal to negative 8 plus root 16 divided by 8. So this is going to give me negative 8 positive 4 divided by 8, which is negative 4 divided by 8, which is negative 1 over 2. But sin x is actually represented by t. Okay, since t is equal to sin x, so this would imply that sin x is equal to negative 1 over 2, which implies that x is equal to 7 pi over 6. The exact, so that's a keyword, x coordinate is x is equal to 7 pi divided by 6. So that is the solution. Students, in the second question, we are expected to find the gradient of the curve, the exact gradient of the curve at A. So what are we going to do? We know that y is equal to 4 times sine squared x positive 8 times sine x positive 3. So differentiating with respect to x, we get, so what do we get? We get dy over dx is equal to 4 times differential of sine squared x is going to be 2 times sine x times differential of sine x will give me cos x positive differential of sine x over here would give me 8 times cos x, differential of 3 is going to be 0. This is 8 times sine x cos x plus 8 times cos x. If I were to take 8 and cos x out, I'm getting sin x positive 1. So this is my dy over dx. Now we are expected to find dy over dx at A. Now at A we have the coordinates as 7 pi over 6 and y coordinate is going to be 0. Right? Now this is nothing but 210 degrees, 0. So substituting at A, we got dy over dx to be equal to 8 times cos 210 degrees times sine 210 degrees positive 1. So this is equal to 8 times. Now cos 210 will give me negative root 3 over 2 and sine 210 will give me negative 1 over 2 positive 1. So that's going to be 8 times. Now I'm just rewriting it. So it's going to be negative 3 over 2, negative root 3 over 2 times. This will give me positive 1 over 2. Now 2 divides 8 4 times, 2 divides 4 2 times. So that's going to be negative 2 times root 3. So this is dy over dx at A. Students, in this question we are expected to find the area of the shaded region. So the area formula is given to be as integral y dx within the limits x is equal to a to x is equal to b. So this is going to be integral x is equal to 0 to x is equal to this point, which is 7 pi over 6, and y is going to be 4 times sine squared x positive 8 times sine x positive 3 times dx. Now I have a formula which says that sine squared x is equal to 1 negative cos 2x divided by 2. So I would be using this formula here. So this is going to be 0 to 7 pi over 6 4 times of 1 negative cos 2x divided by 2 positive 8 times sin x positive 3 times dx. Now 2 divides 4 2 times. So I can rewrite this as integral 0 to 7 pi over 6. 2 times 1 gives me 2. 2 times cos 2x would give me 2 times cos 2x positive 8 times sine x, positive 3 times dx. I can add 3 with 2, so that is going to be integral 0 to 7 pi over 6, 5 negative 2 times cos 2x, positive 8 times sine x times dx. So I have to perform this integration. Now this can be further rewritten as 5 times dx integral 0 to 7 pi over 6 negative 2 times integral 0 to 7 pi divided by 6 times the integrand is cos 2x times dx, positive 8 integral 0 to 7 pi over 6, and the integrand is sine x times dx. Now this will give me, upon integration, 5 of x, the limits are 0 to 7 pi over 6, negative 2 times, integrating cos 2x would give me sine 2x divided by 2, limits are 0 to 7 pi over 6, positive 8 times, integration of sine x would give me negative cos x. Okay, the limits are 0 to 7 pi over 6. Now applying limits, we get, so what do we get when we apply the upper limit for this? It's going to be 5 of 7 pi over 6 negative 0, negative, the 2 and 2 can be cancelled, so this is going to be sine of 2 times of 7 pi over 6 negative, of course sine 0 is 0, so no need to bother. This is going to be negative 8 times cos of 7 pi over 6 negative cos of 0. So this is what we have got. Now this is rewritten as 5 times 7 is going to be 35 pi over 6 negative. Now this is going to be sine of 7 pi divided by 3 negative 8 times cos 7 pi over 6 and positive, now cos 0 is 1, so that's going to be 8 there. So I have to do some rearrangement. So now these two quantities have to be simplified. Okay, now sine 7 pi over 3, this is going to be positive root 3 over 2, and cos 7 pi over 6, this is going to be negative root 3 over 2. Now substituting these values, we would get 35 pi over 6 followed by negative root 3 over 2, and then negative 8 times negative root 3 over 2 positive 8. This is going to be 35 pi over 6 negative root 3 over 2 positive 8 times root 3 over 2 positive 8. These two things can be added, so that would give me 35 pi over 6 positive 7 times root 3 over 2 positive 8. So this is the area that we are talking about, so you need to add square units there, and the statement or a word, the required area is, okay. So this completes the solution for this question.